Hey there, ladies and gentlemen, boys and girls. This one's gonna be a short video on something called wave speed. It's pretty self-explanatory, especially since we've talked a lot about motion already. This is literally wave speed is the speed of a wave. It is how fast a wave can travel through an object, and it really depends on a couple things. It really depends on an object's state of matter and density. Short story, basically, um, for waves to transmit, or are the vehicle which transports energy, and you're going to transport energy from particle to particle to particle to particle. When the particles are very close together, like in a dense material like a solid, those particles don't have to travel very far to pass off that energy. In a less dense object, say like a gas, that particle has to spend a lot of time transferring its energy to the next one before it can go on. So, rule of thumb is that our waves can travel faster through a solid than it can through a gas. Now, there are other things that stop that. Some materials reflect or absorb light energy and things that are in sound energy, and we'll talk more about that. But for when energy travels through something, the more dense it is, the faster it can move, and we can calculate that wave speed. All right, I'm just going to show you real quickly what that formula looks like, and we'll do like one or two examples. All right, so for the formula, all right, wave speed, it's velocity, so we represent that with a v, right? For velocity, how fast, all right, it's going to be equal to that specific wave's wavelength in meters, right, times its frequency. And that's pretty much it. So kind of recapping it with talking about the units, right? So we have speed in meters per second, right? Is equal to, or its wave speed, is the speed of that wave is going to be equal to its wavelength which we measure in meters times its frequency, which we measure, of course, in hertz. All right, so let's just do one or two examples real quick, kind of talking about this, but otherwise it's really much just a straight mathematical equation, a pretty straightforward, easy one too, if I might say so. All right, so I'm not going to do all these ones here. Let's just talk about, let's just do two of them together real quick. So here is our formula here. All right, we have our wave speed, wavelength, and frequency. So let's try number one here. All right, a wave has a distance of 15 meters between its peaks. Well, the difference between its peaks or crests is a measurement of wavelength. So we have 15 meters. All right, 5 of these waves pass every second. Frequency is the number of waves per second. 5 waves per 1 second is 5 hertz. All right, so 15 times 5, that would give us our wave speed. So anyone can do that on the top of their head? 75 meters per second. All right, that wave is traveling at 75 meters per second. All right, example number 2. Wave speed is 20 meters per second. There are 10 meters between the peaks. What is the frequency? And so we have to solve for, in this case, f, right? Solve for f. So 20 equals 10f, right? Do some algebra, divide both sides by 10. 20 divided by 10, you get a frequency is equal to 2. That's a naked number. That's gross and disgusting. 2 hertz. All right, it's 2 waves per second. All right, that's it. That's pretty straightforward. Wave speed is literally just a measurement between that relationship between frequency and wavelength. Something with a very high frequency and a very high wavelength is going to be going very, very fast. But we know from previous relation that there is a relationship between those two, and we'll see a lot more of that, especially when we talk about the electromagnetic spectrum. But otherwise, that's it. There will be some practice, but otherwise, good luck. Good luck with it, and may the science be with you.